Alright, so in this video we're talking about the first video of a two-part sequence talking about trigonometric functions. What you see here are two different graphs. Here up top we have the graph of y equals sine of x and the graph of y equals cosine of x. And these two are the ideal parent functions for the graph of y equals sine of x and the ideal parent function of y equals cosine of x. A couple things about each graph here. First off, the range, or the y values, go from a maximum for capital M of positive 1, a minimum, little m, of negative 1. That's for both graphs. The amplitude for both graphs is 1. That kind of goes from the midline, what I call the midline, or halfway through the wave, to the very top or to the very bottom. And then the period, how long does it take to complete one cycle of the wave for each graph, is 2 pi. Now, a couple of other things that's not listed on this graph is that for the cosine function, for the sine function, let's start there. It always starts, if we're looking at the parent function, always starts at 0, 0. And finishes one period at 0, 0. Or not at 0, 0, at 2 pi 0. Okay, so at 2 pi 0. So the y values are always 0 for the sine function. Looking at the start of the cosine function, again, this is the ideal parent graph. It always starts at its maximum and finishes at its maximum. Now, these two facts are going to come into play as we go on and look at transformed child functions for sine and cosine. Now, a couple more facts that's in your notes. Just scroll down. These facts relate to the picture that we just saw. Each function is periodic. All that means is that the wave has a repeating pattern that's going to continue indefinitely. It's never going to stop unless we put restrictions on it. The maximum value of y equals sine of x is 1, and it occurs at x equals pi halves plus 2n pi. So we could actually calculate each time the maximum occurs because n is just any number. Likewise, the maximum value of cosine of x is 1, and it occurs at 2n pi. The minimum value of y equals sine of x is negative 1, and it happens at x equals 3 pi over 2 plus 2n pi. Again, if we know what n is, we can figure out everywhere for the sine function where the minimum is going to happen. We can do that by hand. And the minimum value of cosine is also negative 1, and it happens at the quantity of 2n plus 1 times pi. Again, if we know what n is, we can figure out where the minimums are. The amplitude of each function for sine and cosine is 1, and we find it by using the maximum value and the minimum value. Pretty much the amplitude is just we take the max minus the minimum and then divide it by 2. So again, what we just saw here in both graphs was the ideal parent graph. Now let's look at the general parent graph of each function. So in general, the graph of the parent sine function is given by y equals a times the sine of bx, where a and b are non-zero real numbers. And likewise, the graph of the parent cosine function is given by y equals a times the cosine of bx. For each function, the amplitude is given by the absolute value of a, and the period is given by 2 pi divided by the absolute value of b. So if we know what numbers a and b are, we can find the amplitude and period of each graph. If we graph each of the functions on the interval 0 to 2 pi over b, and if we get a is positive and b is positive, then for each graph we have 5 key features. Now I'm not going to go through each of these because I just write them out here, so you can read that on your own, but I do want to point out a couple things. Again, like we just saw, sine always starts its period and finishes one period at y equals 0, so the y value is always 0. And for cosine, it always starts its period and finishes its period at its maximum height, in this case, whatever a is. Now, these are the parent functions, so once we start transforming things in the next video, then we want to keep these things in mind, because if we know that, for instance, that sine always is supposed to start at 0, 0, but it's starting somewhere else, then that probably indicates that there's a vertical shift. So just keep that in mind. Likewise, same idea for cosine. We know cosine is supposed to start at its maximum, but if it actually starts at its minimum, then that means there's probably been some type of reflection. So when we move on to the next video and start talking about transforming these parent functions, keep these facts in mind. All right, and in example 30, we have the graph of y equals 2 times the sine of x. So I just want to go through and talk about a couple things. First off, what's A, what's B, so that way we can calculate the amplitude and we can calculate the period of this graph. Again, we know that since it's sine, it always starts its period at 0, y equals 0, and it finishes its period at y equals 0. So, based on the pattern that we had, y equals A sine of bx. Based on this pattern, A is 2 and B is 1. Well, since A is 2, that means the amplitude is the absolute value of 2, or just 2. And since B is 1, we know the period is 2 pi over the absolute value of 1, which is just 2 pi. So again, the amplitude is 2, and it's all that tells us how high up the wave goes from the midline. So right here, obviously the x-axis is the midline. It's kind of cutting this wave in half. And amplitude 2 means that the height of this wave is 2 units. We can clearly see that. 1, 2. So the amplitude is 2. We also know that the period is 2 pi, so that means we start at 0, 0, just looking at it, and we go all the way out to 2 pi. So that's one cycle of the wave. And that kind of makes sense because, again, since it's sine and there's not been any horizontal or vertical shifts, then we know that it starts at 0, y equals 0, and it finishes at y equals 0. Example 31, we have the graph of cosine of 2x. Let's start off with what A and B are. So to do that, I'm going to look at the pattern, A times the cosine of bx. Again, I'm just looking at my parent function. Based on this pattern, I have A equals 1 and B equals 2. Well, A equals 1 tells me my amplitude, which is just the absolute value of 1, is 1. B equals 2 tells me my period for this function is 2 pi over absolute value of 2. So I have the period for this function is just pi. All right, let's start with the fact that it's cosine. Again, we compared it easily to our parent cosine function. There's no horizontal or vertical shifts. I know that because the parent cosine function, I know for a fact, is always supposed to start at its maximum and finish exactly one period at its maximum. And it's doing that, so there's no horizontal shift or no vertical shift. I also know that the amplitude is 1. The amplitude is pretty much the distance from the midpoint of the wave to the top of the wave. So the amplitude is 1. And I know that since the period is pi, that means the wave completes one full cycle. We start at 0 and go all the way to pi. So that's one full cycle. Okay, and obviously we have more than one period shown here on the graph, but that's okay. It just repeats itself over and over again. Okay, and again, there's also no reflection here because I know that the parent cosine function always starts at its maximum. So lots of things there, just knowing that it's the parent function of cosine. In example 32, I have y equals 1/3 cosine of pi x. Let's first compare it to the parent function as much as we can. So y equals 1/3, actually y equals A cosine of bx. So A is 1/3, which means my amplitude is 1/3. Cosine of bx, so B is pi, which means the period is 2 pi over absolute value of pi, which is 2 pi over pi, and just clean it up so the period is 2. So that means I'm going to go from 0 to 2 to complete one cycle of the wave. All right, let's first talk about A, the amplitude. So again, the amplitude is the distance from the midpoint of the wave to the highest point of the wave. So this distance from here to here is supposed to be 1/3. And it is because here's 2/3, so this has to be 1/3, so that makes sense. Also, I know that the period is 2, so it's cosine. So I'm going to start here at 0 and go all the way out to 2. So there's one period of the wave shown. And also, I know that there's been no reflections, because for cosine, I know it's supposed to start at its maximum point and finish at its maximum point. And it does that, so no reflections at all. Also, no vertical shifts, no horizontal shifts. Okay, and the fact that trig functions are periodic is useful because they model oscillating motion. Now, oscillating just means it goes back and forth, kind of like an old-timey oscillating fan. Back and forth, back and forth. That's an oscillating pattern. Some examples are sound waves, the motion of a pendulum or a spring, season of the year. In applications such as these, the reciprocal of the period gives us the frequency, which is the number of cycles per unit of time. So, for instance, the frequency is 1 over whatever the period is, which means, since we know the period formula, it's the frequency is given by the absolute value of b divided by 2 pi. So that takes us to example 33. When you strike a tuning fork, the vibrations cause changes in the pressure of the surrounding air. A middle A tuning fork vibrates with a frequency of 440 hertz, that's cycles per second, and you strike a middle A tuning fork with a force that produces a maximum pressure of 5 pascals. We're going to write a sine model that gives the pressure P as a function of time in seconds. Okay, so we're told to write a sine model that gives P as a function of time. So that means so P is going to be our output, our Y values. As a function of time, that means it's our input, or our X values. Okay, so just keep that in mind. So since we're using sine, we're going to start off with y equals a sine of bx, our parent function that we know. Now, let's go ahead and work on b. Okay, so b is related to the frequency. So since I know the frequency is 440 hertz, that's equal to the absolute value of b over 2 pi. Alright, well, I want to get the absolute value of b by itself. So what I'm going to do then is I'm going to multiply by 2 pi. So I have 880 pi is equal to the absolute value of b. Okay. And so that's positive. I know that's a positive number. So my period, or sorry, b, not the period, b is equal to 880 pi. All right, so now I have y equals a sine of 880 pi x. All right. Now, what we also know is that we produce a maximum force of 5 pascals, a maximum pressure of 5 pascals. So that implies that A is 5, because we know that A is related to the amplitude. And the amplitude is simply the absolute value of A, which is the absolute value of 5 is 5. Now, again, the amplitude, and we said it many times, is just simply the distance from the midline of our sine wave to its maximum value. So the midline is always the x-axis, so y equals 0, and the maximum value is 5. So A equals 5. So we have y equals 5 sine of 880 pi. Okay, so that's our equation. Write a sine model that gives the pressure P as a function of time. So there you go. That's really as easy as it gets. And that takes us to the end of this video. In the next video, we're going to talk about the child function for both sine and cosine waves. If you got any questions, please let me know.